Hello everyone, this is the third lesson on Arduino's C. Today we are first going to talk about arrays. An array stores multiple data values of the same data type in a block of memory, allowing you to reference the variables using the same variable name. It does it through an index value. So the format for arrays, the format is a data type, and then a variable name with the size of the variable. So for example, let's create an integer array. Let's call it my array with, let's say, 3 different different data values. All 3 of them has to be integers. We can define them by using the curly brackets, and then we can say like 10, 21, and 32. These are 3 integers, and the first one on the index is 0, and then it's 0, 1, 2. So instead of starting counting at 1, it starts at 0. So now it's 0, 1, 2, like this. And then if we want to print it out, we can use a for loop for integer I equals 0, I less than 3, then we add 1, and then we can do my array, define the serial manager, serial.begin, and then print a empty line here, and then we can print my array with I. Alright, now let's run this. So we can see it's 10, 21, and 32. It starts running at 0, and then 1, 2, and stops at 3. So arrays can also be used in loops. Another thing to note is that the array, we can have more values in the array. For example, we can have 5, and the last 2 would just be undefined. Like so. And even though it allows 5 values, it only defines 3. And additionally, we also don't have to specify how many there are. We can do this and write 3, and it will default into 3. Like this. Alright, and then to determine the size of an array, you can use the function sizeOf. You can also determine the size of an array using the sizeOf function. For example, size of my array, like so. And then my array calculates in terms of bytes, and so it's 6, and that's because every single integer is 2 bytes. For example, we can change this to my variable, and then an integer of my variable would be, let's say, a random number for integer. This would be, well, forgot the semicolon. Like this, integers is worth 2 bytes, and then a byte should be worth 1 byte. Like this, and then a float should be worth, I think, 4. Yeah, so it's 4. Alright, so this is basic knowledge on arrays. Next, let's talk about strings. Strings are quite important. We are probably going to spend quite a long time on this one. So, a string value is a series of characters put together to create a word or sentence. And then the format is a capital S for string, and then the variable name with text here, and then a semicolon to end it off. Important thing to note is that these quotations are double quotes instead of single quotes. Single quotes can only be used when there's one character, but when there's multiple characters like this for a string, then we use double quotations. Alright, for example, let's come in here, use a capital S string, and then let's say this is string number 1. This will be the variable name. Then we can write hello world. And then we can print string 1. Like so. Alright, it says hello world. And it doesn't have to be letters in the alphabet. It can also be exclamation marks, or even numbers, or spaces. Any characters or symbols work in a string. Alright, so although you can just create a character array, like how we did in the arrays, strings are much easier to work with. They also have more supported functions. And now we go into the functions that can manipulate strings. There is quite a lot, and we're probably going to spend the remainder of this class on here. So method, and then the description of the method. So we're going to go in alphabetical order. First we have character at with one variable n, returns the character at the nth position in the string. So for example, we can make a string more simple. Let's say A, B, C, D, E, F, G. And then we can do string 1 dot or period character at, and then the index is the thing I was talking about before. We start off at 0, so it's 0, 1, 2, 3, 4, 5, 6. Even though there are 7 characters, we start at 0, so we only get to 6. For example, we can look at the character at index 0, like this. And so it's A. If we look at this at 6, then it should be G. Yeah, so G. And if it goes outside of the index, for example, let's do 10, which is clearly outside of this string. Let's see what happens. So now it just does this because it has no idea what we're trying to find. Alright, so after character at, we have compare to, and this requires another string to compare to. So this returns a boolean, which is either 0 or 1. Returns 0 if the string is equal to string 2. A negative number if the string is less than string 2, or a positive number if the string is greater than string 2. So now we can do, let's say, another string 2, and then this can be A, B, C, D, E, F, G, H. Now this is longer, so if we do string 1 dot compare to, and then string 2, now this should return a, oh, I forgot the semicolon, sorry. Now if we compare string 1 to string 2, since string 2 is longer than string 1, it should return a negative number. And it doesn't matter what the number is exactly, it's just a negative number. And then if we make this shorter than string 1, it would become a positive number. So 103, and then if it's the same, then it should return a 0. So 0. Alright, next we have concat, which we need string 2, and then appends adds or appends is the same word, synonyms, the string 2 value to the end of string 1 and creates a new string value. So for example, we can A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. So we can add these two together. Let's do string 1 dot concat string 2, and then we can print string 1. This should be A, B, C, D all the way to P. Oh, I forgot the semicolon. Alright. Yeah, so now it's A all the way to P. Alright, after concat, we have the ends with method, also with a string 2. So this one returns true or 1 if the string ends with the string 2 value. And conversely, if it's false, then it does not end with string 2. So we no longer need this line. String 1 dot ends with string 2. So let's make this D, E, F, G. So obviously this is the same as the end of string 1. So this should return true. So yeah, it's 1, which is true. And if this is obviously wrong, so let's say XYZ, then it should return 0. Yeah, 0. Alright, so after we finish with ends with, we can go on to equals. Equals, and then string 2 returns true if the string is equal to string 2. So if they are the same, A, B, C, D, F, G, then this should be true. Alright, and if this is false, let's say wxyz, which is false, so it will return 0. Yeah, 0. And by the way, this is case sensitive, so if we make this capital, let's say A, B, C, D, E, F, G, all capital, and since this is case sensitive, then these would not equal each other. It would return a false, so 0. Alright. If we want to bypass the case, if it's lowercase or uppercase, there's another method called equals ignore case. Again, string 2 returns true if the string is equal to string 2, ignoring the character case. So now if we change this to ignore case, then this would be true. Like this, so now it's 1. Alright, after ignore case equals ignore case, we have get bytes, and this has a buff and a length. So it copies the length string characters into the buff variable. So since this is get bytes, the buff variable needs to be a byte. So we can do byte myArray, and we will use a method that I haven't taught yet, which is length. This calculates the length of characters inside this string, that while we are not counting the terminating null character, which is characters that we can't see basically. But we have to have that in our calculations, so we add one, and then we do string 1 dot get bytes, the buff, which is myArray, with a length of string 1 dot length plus 1. And then we can do a loop for integer I equals 0, I is less than string 1 dot length plus 1, while, and then we do this. Inside of the loop, we will print myArray one at a time, like this. Don't forget the semicolon this time. Alright. So now we have each of the characters in here represented as a byte. So these numbers, the characters converts into numbers using the ASCII table. For example, we can pull up a picture. This, for example, A is 97, B is 98, C is 99, etc. And in here, we start at 97 and so on. Alright, so this is the get bytes. We use this to make a copy of these string so we can calculate easier, and maybe if we somehow lose data, we can still find the string this way. And then after get bytes, we have index of, and then with a value and a from. Oh yeah, by the way, using the square brackets means that this is a variable that we don't have to include in there, but if we want to, we can. This returns the index location where the string value starts in the string by default, it starts at index 0, which is the beginning, or you can specify a starting location using the from parameter. Returns -1 if value is not found in the string. So let's showcase this. We no longer need this serial.println string1 dot index of, and then let's try and find the character A in here, which should be 0, considering it's the first one. Yeah, so this is 0, and then if we add a character A somewhere else, it would still be 0, because it only finds the first one and then stops trying to find other ones. So now if we don't want it to find this one, then we can specify where we want it to start from. If we say, let's say 2, then it starts at 0, 1, 2. So it starts here. So now it will find this A. So it would be 0, 1, 2, 3. So 3. And this is how you use index of. Now index of starts from the left and goes right, which is like how we read. Another method, which is the complete opposite, scans from the other way. It is last index of, which is a value, another from, and then returns the index location where the string value starts in a string. By default, it starts at the end of the string, working toward the front of the string. Or you can specify a starting location using the from parameter. Returns -1 if val is not found in the string. So here, without specifying anything, it should find this one. And although it starts scanning from the end, the index still starts counting at the left. So this would be 0, 1, 2, 3, 4, 5, 6, 7. So 7, 6, 5, 4, 3. So it should still be a 3. Oh, I forgot to change the index of. I'm so sorry. That should be last index of. Now it should be 3, since it starts looking from the right to the left. Alright, so that's 3. And if we want to bypass this one, then we can start at, let's say, 2. This way it should start here on C and then go to the left. So it finds 0. Alright, after this, we have one of the most important methods, which is called length. So this returns the number of characters in the string, which is not including the terminating null character. And the terminating null character is basically a character that tells the computer that this string has finished. And it's not seen anywhere on the string, even if we print it. And it's just for the computer. If we find the length of this string 1, it should be 1, 2, 3, 4, 5, 6, 7, 8. Oh, let's erase the A in the middle. So 7. 1, 2, 3, 4, 5, 6, 7. So string 1 should have a length of 7. Alright, yes. After length, we have replace, which we can replace substring 1 with substring 2. Returns a new string with the substring 1 value with substring 2 in the original string value. So for example, we can write string 1 dot replace, let's replace A with B, and then we can print string 1. Now it should be B, B, C, D, E, F, G. Alright, now it's B, B, C, D, E, F, G. And it doesn't have to be only one character. If we want to replace ABC with XYZ, then we can do that. It would be XYZ DEFG. Alright, after replace, we have reserve. Now, I can't really showcase this one, but I can tell you the theory for it. It reserves a space of n characters in the memory for a string value. So this reserves characters after the string where we can add more onto it in case we need to. And I can't really showcase this one. And let's continue. Starts with string 2, returns true if the string starts with string 2. So if this is AB, and then we can have a string 2, which is ABC, and then serial print line of string 1 dot starts with string 2. So now ABCDFG starts with AB. Oh, I forgot the semicolon. So ABCDFG starts with ABC, so this should be true, returning a 1. Alright, now it's 1. After starts with, we have substring from 2. So this is returns a substring of the original string value, starting at the from index location, and by default, it returns the rest of the string from that location. Or you can specify the to index value. So we can substring, and then we can start at, let's say 0, or let's say 2, and it goes to the end. So this should start 0, 1, 2. So it starts at over here and goes all the way to G. So C, D, F, G. And then we can also specify where it ends. Let's say 5. So now it should be 1, 2. So it starts at C and goes to 3, 4, 5, F. But it does not include F, because for C, it includes the starting one and doesn't include the last one. So now, let's see, this should only be C, D, E. And let's see, yeah, so this is only C, D, E. If we want to go to the end, while writing something here, we can say -1. This means to the end. It's the same in C and Python. So now this is substring and 2 to the end, which is C, D, E, F, G. Alright. And then we have 2 character array. This one is like the byte one. We have a buffer and a length, and copies the length characters in the string to the character array variable buff. So this is a character array, so character my array, and then we can specify string1.length plus 1, and then we write string1.to character array, writes it into my array with a length of string1.length plus 1, and then we can write a for loop again, integer I equals 0, and then I, while it's less than string1.length plus 1, and then we add 1, and then we can print the array with the index of I, and now it should use, oh, I forgot something. We do not need that. So now it should print out each character in the string, and like this. So A, B, C, D, E, F, G. Alright, after two character array, we have two integer. This returns an integer value created from the string value. The string must start with a numeric character, and the conversion stops at the first non-numeric character in the string. So two integer. For example, we can write serial.println string1.to integer, and we can add, let's say 1, 2, 3, 4, 5, and we can have an integer of 12,345. Oh, did I forget something? Oh, I forgot to add the finishing curly bracket for the void setup. And yeah, it has 1, 2, 3, 4, 5. And as soon as it sees a non-numeric character, it stops. So if after the A we have another 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, then it would stop at the A and no longer convert to integer. So this would still be a 1, 2, 3, 4, 5. Alright, after two integer, we have set character at an index and a C, which is a character. Replace the character at index with the character C, which is variable C, and then we can write set character at, let's say, okay, we can erase all the numbers in this string. Let's say index 2, which is the third one, 0, 1, 2, C, and we can change it into a character which, using the ASCII, let's say 67, and using the ASCII table, or why is this wrong? Oh, the T is not capital. Oh yeah, I forgot. This string has to be outside of the print, like this. My mistake. I forgot the semicolons. Wow, series of mistakes. Like this. So now the character C in the first few letters of the alphabet goes from a lowercase to a capital C. That's kind of cool. 67 is capital C, alright. This is capital A. Alright, next we have 2 lowercase. Converts the string value to all lowercase letters. So for example, if we have A, B, C, D, E, F, G, we'll leave for that many. And then in here we do string 1 dot 2 lowercase. Then it would be lowercase A, B, C, D, E, F, G. Oh, does this also need to be written outside? Alright. So this is 2 lowercase. Then, like this. Alright, so it's all lowercase. And if there is a method to convert it to all lowercases, then all to uppercase naturally comes next. Converts the string value to all uppercase letters. So if we start with lowercase, and we can write to uppercase, now this should be capital A, B, C, D, E, F, G. Let's see. Like so, A, B, C, D, E, F, G. And last but not least, we have trim. So this method removes any leading and trailing space or tab characters from the string value. So for example, we can not trim. Let's add a few spaces and a few tabs at the end. Now like this, string 1 would be trimmed into this right here. And if we don't have this line, then let's showcase how it would look. Alright, so this is the difference. This one has a bunch of leading and trailing spaces, while this one got rid of all of them. Alright, so these are all of the methods. I know there were quite a lot. So we covered arrays and strings today. And for the homework today, let's say convert a string to all uppercase. And let's specify convert the string, let's say W for T is the best, to all uppercase. So it should output a W for T is the best, like that. Alright, try to get this to work using the to uppercase method. And that's all for this lesson. Thank you.